I've never paid for one. So let me know when you
Well,
guys want me to start. I'm really happy to just start chatting whenever. I guess I'm chatting now, but
we can start now. It's 1:06. So yeah.
yeah, okay. Well, this is awesome. Well, thank you so much. I mean, I'm really thrilled to be able to speak to you. It's a Saturday. I mean, so Saturdays, like there's so much more to be doing. I think it's Super Bowl in America tomorrow, like Super Bowl Sunday, and I was out for a run this morning and people told me there was loads of stuff going on. So whatever it is that you want to ask me or talk about to me or get me to talk to you about, this can go anywhere, literally. Like you can just drive the bus, if that makes sense. Um,
Mhm.
so whatever it is that's on your mind, I've got like some charts I can show, I can talk through what I think you might want to hear about or what I may have wanted to hear about when I was at university before getting a career in computing. Um, so I can try and sort of project what I think you want to learn about. I'll start with that, and then if there's anything that if I'm completely off course or just interrupt me, just completely interrupt me. Um, and initially, I think this changed changed titles. Um, Initially, I think it was going to be quite like an introduction to ZOS and a career in mainframes. And then I was going to have a bit of a slant about open source, but I'll try and sort of blend the two together. So I'll get a little bit of background about myself. I have no degree in IT at all. Um, I trained to be a geneticist, so lots of life sciences, biochemistry. Um, Most people, when you say I understand genetics, they think of like, DNA and sort of double helix and which is a kind of it's basically the encoding for how a cell makes proteins. It's not binary. It's a kind of a sort of triplicate code where three base pairs are encoded into an amino acid. It's a protein, but it's a really interesting topic. And most people also know DNA because when a cell divides, it kind of like it's like it unzips and then kind of like each half of the zipper creates its own zipper, and then you get like the nucleus divides and you get what's called meiosis. So that's basically the cell growth, right, which is sort of life, and then in sort of sexual reproduction, then half of the DNA from each parent basically creates a new individual. Right, so that's the kind of, and then that kicks into sort of Darwin and survival of the fittest and blah blah. So that has nothing to do with IT. But my background is that when I first when I was doing IT, it was a long time ago. It's like 1988 when I did my master's degree, and I remember at the time computers were. I've got some slides, but I'll just sort of talk it through. I mean, you literally had to go into a room, log in. It was a big green screen, a big black screen, which is like green text, no graphics. Um, you would write a program. It was just a disaster. It was like it. It wasn't a disaster, but it was very, very difficult to get anything done. You had to have an idea, and then to get the response from that idea, you literally had to wait until the next day. So there was so much. It wasn't very cerebral. So I didn't know if anybody in the call are musicians, right? But I was playing the piano at the time. And what's wonderful about the piano is that you can play a chord and it doesn't sound quite right, and you just play it again. When you touch a keyboard, the feedback for whether you've made a mistake or whether it sounded the way that you wanted to is instantaneous. And there's something wonderful about that. If you can do things at the speed where you think about something and you can turn that into reality and then iterate it and riff on it, it's what folks call sort of agile now. And that wasn't the world. And I remember the first time seeing an Apple Mac computer, what's called the Mac 2E at the time. It's the first graphical user interface computer that was commercially available, where you could drag and drop and the graphical user interface. I remember thinking, I'd quite like to have a career in IT. This is more interesting than biochemistry. And I got involved in computing. So what's interesting, I mean, I suppose the one thing, and I'm sort of towards the sort of tail end of my career. Like, I'll probably retire in the next 10 years. My advice to anybody starting your career is do what you enjoy, do what you're passionate about. Um, there's a Japanese phrase called ikagai, and it basically talks about, actually, maybe I'll start screen sharing a little bit. Otherwise, you have to just end up looking at me. And then I will get onto mainframes in a second. Sorry. And yeah, so this is what I wish. I sound very patronizing, so apologies for this. This is kind of what I wish I suppose the things that have gone. So Ikigai is, I just pick that diagram here. So let me just pick an image. It's a Japanese concept, and I love very much kind of, it's, come on, make that image bigger. Okay, so it basically talks about, there's four things generally that we're confronted with every day. Talks about how to sort of get through life. There is what you're good at. And my guess is if you're all doing a degree right now and you're all doing a degree in IT, you're good at it, yeah? And it's also what you love. Otherwise, you wouldn't be doing it, right? So most people generally do what they love and do what they're good at. That doesn't always intersect. You could love singing and not be very good at it. That doesn't mean you should stop singing. It just means you should, you're not going to be a concert performer, but that's what karaoke bars are for, and singing in the shower and stuff like that, right? And having family that, but you should always do what you love. That's why it's the most important one. So my experience is most people who work in IT are generally quite mathematical. They're quite cerebral thinkers. They're generally quite introvert. They don't want to be salespeople. They don't want to be medics. They don't want to cut, deal with being a medic is wonderful, but most of us are probably quite queasy when we see blood. We don't want to sort of cut bodies open and stitch them together. That's a wonderful profession. Do what you're good at. But then the other two is what you can be paid for and what the world needs. And I'm going to talk about what the world needs in the concept of mainframes and what you can be paid for. I'll talk about those two. So what you love, my guess is you're probably already doing what you enjoy and you're doing what you're good at. You've probably taken some specializations. So now I'm going to talk about what the world needs. And by the way, when you can get all four of these right, basically life is good. Okay. What you can be paid for. So there are interesting ways to get hired by mainframe companies. I'll talk about what the world needs, and then I'll eventually talk about that. So let me very quickly jump to my presentation. No, let me not. Let me just go back into. So here's the basic problem we had back in 1966, which is a long time ago. Sorry, I'm just literally messing around with my laptop right now. Okay, so back in 1966, which was a long time ago, basically, let me see if I can actually, let me just do this again. So back in 1996, this particular computer was invented, and this is literally a photograph of it. It's called the IBM System 360, and it is basically the sort of great grandparent of what's called the IBM Z platform now. It is completely 100% different. There is no hardware similarity whatsoever. I mean, this ran with valves and transistors and just all sorts of stuff. And there's loads of history lessons. The interesting thing about this computer right now is the time it was built. So before it was built, almost all banks literally had paper records of people's bank accounts. All government agencies like driving licenses, the land registry, everything was literally done manually. But and this really was the computer that sort of powered the kind of, and I suppose it was almost like an industrial revolution. If you think about the industrial revolution in Britain in the kind of 1800s and 1700s, it was literally, how can we mechanize making fabrics? How can we mechanize making, pots and pans? So rather than having kind of villagers and crofters doing it all by hand, people literally came together to do that at industrial scale. And there's weaving machines and were created. The spinning jenny is a weaving machine. Lots of mechanization. The railways, the canals. Back in the sort of Britain and other parts of Europe, and it just utterly changed the world, changed the demographic. People started living in towns and cities that then needed more transport infrastructure, needed education. So sort of rather than small village schools, education done at scale. But and it literally, that particular computer, the IBM System 36. The gift and the curse of the gift and the curse. Code written in 1966 still runs today. Right. So if a company in 1966 said, okay, we're going to write the piece of software that is the ledger, is the means that at the end of every day we can work out how much money people have in our bank account and make sure that we keep everything together. Some of that code is still running today. I work with companies, perhaps not the 1960s, but certainly the 1980s and the 1990s and the noughties. That particular code is still running. And during that kind of tail end of the century, last millennium, that is when basically banks became more automated. Internally, banks became more automated. So when you went to a bank and you gave them something, the teller behind the desk, the bank clerk would basically enter it into a computer, and those computers got big and they got very powerful, and mainframes run the world. And this is basically true. It says 71% of Fortune 500 companies use mainframes. I think that is actually slightly higher. I just got that off a T-shirt. So the mainframes do run the world. So these huge, large institutions did this. The problem, and then what happened at the end of the last millennium? A problem appeared, a massive problem appeared called the Y2K problem. And you might already know this, but I'll very quickly summarize. So back in the 1980s and 90s, none of the modern programming languages like, Java or Python, and none of that stuff existed. Unix hadn't been created. But because this computer could keep running, there was no need for a business to upgrade it. But there's a phrase in IT that said, if it ain't broke, don't fix it. So very quickly, the Y2K problem, you might already be aware, and I've got a little bit of animation. So this is a particular way in COBOL you define a year, month, and a day. Now back in 1970 and 1980, storage was expensive, right? So when you're defining a year, if you're creating a database for a year, you would have to say how many bytes you would allocate for that year. And a day obviously goes from 01 to 31 is the maximum of the days we have in a month. So that's quite easy. That only needs 2 bytes. A month is only 12 months in a year. That's quite easy. That means 2 bytes. And for a year, you're back in 1974 and you're writing a program, you would just literally say, well, I'm going to reserve 2. I'm going to call it 7.4. Okay. So that's what you would do. And imagine you are an insurance company back in 88 or something like that. You're writing a program. You have to store when somebody takes out the inception date for insurance policy and when it's going to expire. And that's really important, right? And you're writing a piece of software, and you perhaps every night you have to say, well, which policies have expired or which policies are about to expire? Let's go email the customer. Let's go send them a letter or whatever it is. Email didn't exist back then, so you send them a letter. And you basically say, well, if the inception date is greater than the expiry date, enter a valid policy date. Also, if you're writing a user interface and you want to validate, and you would literally go, oh, well, the inception date is 74 and the expiry date is 75. It's good. So what you're doing is you're basically saying year, month, day. You're putting your 2 dates together and you're just doing a comparison. So the year is the highest part, the most significant, leftmost part of a date, year, month, day. And that's very straightforward. And that even holds today. I could even say, what's today's date? The 7th of February. That would be 2602. 07 and the expiry date could be 27, and that works very well apart from when you go through a century boundary, because you can 27th of August 1990, you change the 89 to the 90, that works. The problem is when you go through a century boundary, August 1999, you go to 00, 00 is clearly less than 99. So there was this massive problem that faced the world back in the 1990s, which was the Y2K bug. And the Y2K bug was fixed. So all of this software was fixed. And banks invested a huge amount of money in fixing all of this software, modernizing it. And as a result of that, there's this whole series of people now working in computing who were hired by the banks to fix it. And they're sometimes called the bug babies. And they're called the bug babies because generally they would have been about sort of 20 to 30 years old at the time. The millennium was what, 26 years ago. So you'll see a lot of people who were sort of 45-year-old and plus who are the bug babies, who were hired by companies to fix those computers. And that's great. Most of them, a lot of them are very close to retirement right now. By the way, I found this online. I thought this would be quite humorous. Airline keeps mistaking a 101-year-old woman for a baby. This is 2024. But what basically happened is this poor woman, she keeps booking her tickets. And because she's 101 years old, American Airlines thinks she's 1 year old. So you can see, even though these systems have been fixed, they haven't quite been fixed, right? There's still a lot of examples of once you get over 100 years old, right, your airline thinks you're 1 year old and it gives you a baby seat and not a wheelchair and stuff like that. So it's not fixed. There are still massive problems, right? So all of these computing systems are still running. Now, since the millennium has come along, there's been a massive amount of need to change all of the systems. Right, the internet was created, mobile phones were created. Everything went from being analog data to digital data to 5G phones can connect. The market, the need for all of these computing systems that power the world to be modernized is phenomenal. So there's a whole generation now where all of these companies are now massively wanting people who understand new technology, but also understand the old technology as well. Because the purpose it's a little bit like, I can see if I can find another Google search. There's a very good book, and it's called Sharing Buildings book. What's it? No, it's called How Buildings Learn. And I'm sorry, I'm just free formatting on the internet right now, so apologies if it doesn't quite work. But it's a wonderful book written by Stuart Brand. And what Stuart Brand has done is he talks about, if I go and look at, sorry, let me just open that image in a new tab. That's not really what I wanted to do. Anyway, let's have a look at that picture over there. We can see. So this is an old building in, I think it's Charleston. And this is a building that's built hundreds and hundreds of years ago, probably 1800 and something. The doors are roughly the same, the window, but as it's been modernized, new bits have been added. The most valuable buildings sometimes are ones where what you do is you don't raise the building to the ground and build it all up again. That's hugely expensive. And during the time that you do that, nobody can live in the building. Right, the building is a building site, right? You have to rehouse everybody. There are times when that works. The building might not be fit for purpose anymore. You might want to repurpose it. But being able to keep a building where it is and repurpose that building is generally better. It's cheaper. It happens all the time. You see it all the time over London right now. Old office blocks are being repurposed into flats and hotels and things like that. Is if you're a bank and you were to just literally, that's the equivalent of your IT. If you would just raise it to the ground and build it, what would you say to your customers, right? They go, well, I still want to buy things. I still want to be able to bank with you. You simply cannot do it. The option of tearing down the IT infrastructure of all of the world's banks and government agencies and airlines and stuff, all of which was created in the last millennium, is just such a huge task that that company will just go out of business. It's simply not possible. So coming back to that, Ekaji, what the world needs is people right now who are able to understand mobile applications, understand internet, TCP/IP, lots of different authentication models, all of that wonderful new stuff, understand rich toolkits for writing rich interfaces, API keys, but also understand the old stuff. Because if you go into an old building and you maintain it, you sort of have to know what was there before, so you can evolve and adapt that to the new form factors. I mean, these buildings now will have, central heating and all sorts of incredible things that probably underfloor heating that didn't exist then. So the skill that's required for that is hugely important, right? The world needs people who can understand that world, and that's the fourth sort of kind of third corner of Akaji. Let me see what I've got. So I'll just slip through these slides. So back in 1974, by the way, have you guys seen what a mainframe looks like or logged into one at all? I don't know if anybody's seen one or no? You guys want to come off mute or something? I don't know. So I'll show you.
No.
Okay. You haven't? Okay, so all right, no problem. So I'll very quickly, by the way, sorry?
I said some of us have seen mainframes.
Oh, okay. Have you seen a green screen? 3270 emulator?
Yes.
You have. Okay. So I'm going to quickly show you. So this was invented in 1974. And I'm just going to see if it works right now. And I'm logging on. And I'm going to do something real simple. I mean, this is a menu to drive it. I have to type the option 3 because that's option 3. I have to type option 4. It's not very colorful. I've only got, I think, 8 colors. Only 4 are being used right now. Well, there's black, which is no color. I've got white. I've got some light blue, a little bit of purple. I have to go. This is effectively the equivalent of a Windows Explorer. I can go down here. I'm using the space bar. I'm listing files. If I want to know what I can do with this one, if I right mouse click it, it's just the right mouse click because my MacBook knows I'm in a text field, right? If I want to know all of the commands I can do, so I've got no right mouse click menu. I have to hit a slash. I have to hit 3 for browse. Browse is weird. Browse is really a list. So what we've got, and if I want to edit a file, I have to type in E against the file. And even then, I haven't really got any help text. So I have to use the arrow key. In 1974, this was state of the art, right? But the problem you've got right now is it's hard to use, right? Even I know how to use this just because I've got muscle memory. It's difficult to use. The analogy, and now if I want to go back, I've got no back keys. I have to know that I can hit function key 3, which I can do that if I want, but it's on my MacBook. Actually, that didn't work. Oh, PA3, so function key 3. It's very difficult to learn. It reminds me a little bit, I don't know if any musicians are in the room. So I learned to play the piano when I was younger, and the piano is a very forgiving instrument, which is why you learn it because you just see a note written on the music score. You see it on the keyboard, you push a button and it gets it right. It's marvelous, yeah. And you can use all the 10 fingers that you have in your hand to sort of, make music. An instrument like a violin or a cello or is much harder. Your finger has to be in the right position. You have to bow it correctly. You have to tune the instrument. A lot harder. You're dealing with an instrument that's much older than a piano. And to be a good violinist probably takes about 10 years. Probably takes about a decade or maybe 8 years, of 6 years if you're very good, to become a sort of grade 8 pianist. But violins, once you become a violinist, you can't then instantly go. You might be able to play the viola or something like that, a similar instrument, but you can't instantly switch to become a really good trumpet player. You'd have to learn all over again. There'd be some advantage having learned one instrument, but it's very difficult to do. You specialize in one instrument, and you'll be brilliant, and you'll retire out being a music teacher or a musician in that instrument. Now, piano is easy for me because if you learn to play a piano, and you learn to play the piano and you want to play something different on a good electric piano, you can hit a button and say, make it sound like a violin, like it's a piano, and it sounds like a violin. And I suppose that's really what the need for people entering the IT right now in computing is. What we don't want, nobody logs into a computer that can only do this, right? Most of us are on our laptops, right? And laptops are much more powerful. I mean, I'm doing this on my laptop. I've got PowerPoint. So the problem that you've got right now is that to use a mainframe, somebody has to go back in time to 1974, right? They have to learn to play the cello, learn to play the trumpet, learn to play green screen. And that's okay. But what we really want to do is we basically want to do, and I'm just going to very quickly show you this. I don't know if you've seen this already, but so this is Visual Studio Code. Visual Studio Code is just marvelous. It's great for working with Python and things like that. You know, if I don't know what to do on this particular system, I can just it's going to work. You know, I can just go and do things, and I can open files, and that was the file I was looking at just now. And if I want to type sort, I just start typing sort, and you know, there's magic, right? It's not magic. I mean, but it's much easier to use. If I don't know what to do, I can right mouse click, I can do things. And the need right now is there's a whole need within all of the banks to basically say, I want to create software like this that makes the mainframe as easy to use, so that folks, presumably you're quite familiar with Visual Studio Code or IntelliJ or something like that, that all of these wonderful things that have been built since 1974, you can just literally hit a button or get a plugin and say, I want to make that work with the mainframe. And including AI, right? There's a huge move right now where people say, I want to be able to understand logs. So I'll give an example right now. The way traditionally, and apology, ask me any questions if you want, but there's something called log. In this mainframe computer, which I'm logged onto right now, you know, I have to type like right 40. I haven't got a scroll bar, and you know, I literally can see I've got a problem. Digital certificate is defined to reserve user ID. So I've got something interesting. You know, right now I can go and understand how to do this by Googling for that. But it would be much nicer to have AI sort of reading all of that. So what I'm going to do now is I'm going to pivot a little bit towards how I think you guys could sort of help with that and how to do. So the first most important thing is to understand, you sort of have to understand this world, but you have to be able to speak in terms of what mainframes are, what mainframes do. So first of all, I'm just going to stop right there. Have anybody got any questions on what I just showed, which is basically the Ikaji of what the world needs right now? What the world needs right now is to bring modern software, modern ideas about using AI, using agentic models, using modern languages like Python or Java or Node or Golang to the mainframe, so that all of the banks and government institutions and everybody all over the world don't have to go out of business. They don't have to bulldoze their building. They can literally just add in extra layers, extra skin. If you look at how buildings learn, this is quite an interesting diagram that they have here, is a good modern building right now, you know, it's easy to change the furniture. It's easy to redecorate it. It's generally easy to do, you know, the plumbing. If you have to rewire it, well, people will put the pipes in ways that are accessible, where you don't have to tear the building apart to redo it. You know, the things that you do need to change, you know, the fuse boxes, the boilers are all more easily accessible. So you want to architect systems so that you can basically change the skin of the building without tearing it down. And that's mostly what the need that people need to do right now. And there's a huge demand for it right now. So the first way to get the first advice that I would suggest you all to do, if you haven't already, is basically, so let's assume that somebody came to me and said, oh, I want to get a job with you, or they gave me their resume or something like that. They wouldn't come directly to me. It would become the very first thing I will do is I will literally Google that person's name, which sounds really bad, right? But we literally Google that person's name, and it's kind of cool. I've been doing this for a while, and I'm not bragging, but what I'm saying is that you need to build up some eminence. You need to build up a sort of online digital portfolio, right? And I'm quite lucky. I've been doing this for a while, and my name just comes up and says cool stuff about me. But Google your name, and the way it comes up, it's fairly easy to see it. Well, look, it just all it did was it trawled 9 sites, about things that I've done, conferences I've spoken to, virtual conferences and stuff like that. So it's really important for all of you to be able to build something, put it out there, put out something useful with your name behind it. Little plug right now. We do have a conference, just because I'm kind of overselling this. If you guys want to, there is a GS UK virtual conference. Call for papers is open. Okay, I literally just found that just from googling around. If you need to, I can send that to you afterwards. There's a virtual conference is very difficult to attend. I know some of you, I think, attended GS UK in person, but it's difficult to attend conferences. And even if you attend, which is wonderful, you're only speaking to the other people in the room. Virtual conferences are great. So GS UK virtual. If you guys want to submit a talk to this or be part of a panel, just let me know. So every time you do all of this, you will increase your technical eminence. It will be reported on websites that Google searches will query to say who you are. So virtual conferences are great. Anybody can sort of self-publish on YouTube and things like that. That's a wonderful thing to do. But so the first thing we want to be able to do is say, how do I have access to a mainframe platform? So the best way to get access to a mainframe platform, I think it's the only way I'm aware of, is IBM provides mainframe access for free to anybody in the world who wants to learn, and it's called the IBM Z Explore Learning Platform. So IBM Z Explore Learning Platform, you just get started, you sign up, there's lots of cool videos, and you can basically just learn. That is probably one of the best ways to learn mainframe skills. Now, within the mainframe environments, you have different kinds of individuals, different personas. So one persona will be a developer whose job it is to write software. So I've written software for banks, but I've never worked in the IT department of a bank. Right, the people who make sure that the bank software runs 24/7, 365 days a year, those engineers are not the ones who wrote the software. Those are the system programmers or the DBAs, database administrators, if it's databases, who are excellent at just keeping everything running. It's a bit like in a restaurant, I suppose you can have chefs behind the scenes, who make the meals, and that's great. And they just churn out meals. They're sort of the developers in a way. They peel the potatoes, they poach the fish, do whatever it is to make the meals. But then the sort of front of house staff are the ones who work out, take the plates to the customers, clear them away from food, make sure that all the customers have got, reservations and all those things like that. They're completely different personas, right? You can be a chef, or you can be a sort of, waiter or waitress. You're working for the same industry, but it's utterly different skills, completely different skills, right? Kitchen that's hot, full of people probably swearing and yelling and throwing pots and pans around and doing a very difficult job. So the IBM Z Explore Learning Platform is very, very good for becoming the DBA or the system programmer. There's another one that I'd like to talk to you about, which is called Open Mainframe COBOL Education. So interestingly, there is it's a kind of a weird problem you've got entering the mainframe world, is that COBOL is the most popular programming language in the world, not because everybody right now is learning COBOL and writing COBOL. They're not. It's very much a sort of dead programming language. But because so much of that code written in the 1970s and 80s and 90s and even the early noughties was written in COBOL, the weight and volume of that propping up the industries is vast. So there is a huge skill shortage in people who understand COBOL. And we do have, let me just quickly go and have a look. This is sort of open source. There is a open mainframe project has what's called a COBOL education training course. Fairly easy to do, completely free to do. When you get it at the end, you will get a badge. So I don't know if you guys are into badges. Credly, I think it's called Credly badge. Just going to go and see it. I haven't done this for a while. Is it Credly by Pearson? Sign in. Sorry about this. So another thing that I really recommend you do is get badges, right? So what have I got? I don't know. I've got 32 badges. But you will get badges. That was a conference I spoke at last year, and they gave me a badge. So badges are good. Badges basically demonstrate. Where's my homepage dashboard? Maybe. Sorry about that. I didn't know why. I would expect that to be a sort of hyperlink. But share your journey. I don't want to share that badge. Maybe it's under profile. Yeah, here are your badges. Here are your badges. So if you go and have once you do the Open Mainframe Project COBOL education class, you will get a badge. That's good. Badges are good. It's not easy to do the badge, but I wouldn't expect it to be a walk in the park for you. But one more thing I wanted to show you quickly is I'll just see if I can pull it up quickly. No, sorry, I'm just literally on my other screen. I'm trying to find out.
Welcome, everyone, to the second of our COBOL Fridays webinar.
Sorry, I'm just getting rid of that. I'm just looking at the screen, COBOL Fridays. So if you just go onto YouTube, what you'll do is you'll see that the other thing is get involved with communities. Here, that's what I was looking for. There's something called COBOL Fridays, and it happens on a Friday. It's super geeky. There's a lot better things you can do on a Friday. But what the COBOL Friday people do is, that's Sudarshan Srinivasan, who's a phenomenal COBOL developer at IBM. I didn't recognize him. Bob Jeff. Anyway, what they do is they literally get together and they share and they talk about meet the next, and they've got lots of videos in the sort of video archive and things. And what they really did was they got together to basically collectively during the pandemic sort of online try to sort of help fix COBOL programs. So I think it's really important to understand that persona of the COBOL developer and do some of these classes. Other things that I think would be possibly interesting for you guys to think about doing is, I don't know if you guys know about Systems Ed enthusiasts on Discord. So I'll start with how I know this. 7nines.com. There's a website. Don't worry about it. That's just because it's got a bad certificate. If we go and look at that certificate, it's anyway that it must have expired, or the signing authority has expired or something. But there's nothing wrong with that website. So 7nines.com is run by a group of people who are very they're non-mainframers, they're Linux people. They've come to the mainframe. They sell t-shirts and stuff like that. But they have on Discord, you just can go here to get the invitation, and you can direct message people. They've got lots of interesting channels. They've got one for general ZOS, and I'm literally going to pick. And you've got people asking difficult questions. They're very, very friendly. They mess about. They post memes. It's almost like a sort of gamer channel. They even have a whole bit called memes where they just mess about and kind of, you know, have kind of nerdy fun together and stuff like that. But they do also have a channels called Introductions. They've got ones called General Careers. I really recommend. That's Niall Ashley, who works for Vitalit. I think he's a student. I think he may have been a University of Wolverhampton student actually, some years back. So you've got lots of incredible people hanging out on here and just chatting. It's a very good thing to do. And what's interesting about that as well is there are quite a lot of. So I work on a project called Zoe, which is open source. There's one called Z Open Community, which is open source. All of these projects have needs. There's one called CBT Tape that's open source. So all of these projects have needs. And I'm going to go to github.com/Zoe. So again, if you're thinking about building your sort of eminence, so what I showed you just now, I showed you Visual Studio Code, and an awesome thing to be able to do was you as a user. So the best chefs are the ones who have the best taste buds, right? You know, the best musicians are the ones who have perfect pitch and really good ears and things like that. So you know, and chefs are constantly tasting the food and seasoning it to be perfect. So if you're using this, for example, which is Visual Studio Code, and you're using it on IBM Z Explore, it might be possible that you will use it and then realize something's a little bit clunky. And I'll show an example of where something's a little bit clunky in this. Let me go there, Etsy syslogd. So I've just gone down to a particular, that was a, oops, sorry, I just made a little mistake. Okay, so this is a directory tree, and I'm drilling down and I'm drilling down, and you can see as I drill down and down and down and down, after a while, you know, I just get lost. I'm like 7 sublevels deep. You know, it's messy, and then you might want to do this, which is where you just literally focus. You're kind of making this become the parent, and then it's a bit like in Linux, you can go cd ... And what a particular user wanted to do, he's called Josh Waters. He literally wanted to be able to do this, just, you know, pop his navigate up. He was using it. This is written in TypeScript. TypeScript is just, and so rather than just sort of throwing rocks at it and barking at the moon, you can go here, you can go to the repository. Just going to Google for it quickly now. And Zoe Explorer VS Code, that's the repository for it. Look at the issues. In all of the issues for this repository, and there's lots, these are all open. How many open? So we have 269 open issues. You can always search an issue, and there's a label as well called good first issue. Where's good? Yeah, good first time issue, good for newcomers. So what's happened is there are 13 issues in this repository, and this literally changes from week to week, where people have said, you know what, we need a bit of help. And it's fairly easy to do, but the main squad of committers, they're just too busy doing other things, you know, that are perhaps a bit more, you know, and these are interesting ones. So Andrew Harner's opened this, and Billy's opened it 3 weeks ago. This is actually Josh Walters, and this person, Josh Walters, he's a very, very, yeah, I think he's like 22 or something like that. He works for Next to a huge UK retailer. And he's really making a name for himself because he literally went in and he added that feature. He actually gave a presentation recently. Let me see if it's here. GS UK, Josh Waters. I think it's wonderful. Complainer to committer. And you see where I can't spell it anymore. Yeah, so Josh actually gave a presentation last November, and it was called okay, the presentation was literally called From Complainer to Committer. I don't know why it didn't find that. Yeah, From Complainer to Committer. So what you've got is, and Josh is really making a name for himself right now, doing this. There are other students I know who are going in and they're picking up something, either because somebody else had said, oh, I'd like to be able to do that, or just going in and saying, you know, it kind of sucks. And that's my thing about open source. So open source software, it's not just about taking something where the source code is made public, if you can cross over to becoming a contributor, where you can contribute, it's a wonderful system. It's kind of like democracy in action. It's almost like the kind of Roman forums back in the sort of 2000 years ago, where you're ruled by the people for the people. If you can start going in and saying, this particular feature is not quite right, here's an issue, I'm going to do something. This software can always, always, always be made better for the use case and scenario. And that's something I'd really encourage folks to do. I did it early on in my career, and it instantly propels you. You also, your GitHub profile, I mean, that's mine now. It will say, which repositories you get points, you get credits. I know when Microsoft own GitHub, literally the first thing they do is they say, well, what are your contributions to answering questions on Stack Overflow? What are your contributions to public Git repositories? Oops, sorry, I'll just cancel. I got some pop-ups there. So that's a really, really good way to go. One thing I just want to quickly point out is, and there is goodness at the end of the rainbow for this. So there's a bunch of incredible students at the NIU, North Illinois University, there in the USA, and they've just created, they themselves found learning ZOS difficult. And what these students did, I'll quickly go into LinkedIn. I'll see if I can find something by Z Crafter. So what they did, with the help of their professor, sorry about this, just literally Googling around. They basically created, and that's Victor Taiwo there, and that's Abijawa, and yeah, that's Victor there. And they, as part of their curriculum, they said, you know what, we actually want to have some kind of, almost like an agentic interaction model with the mainframe. So they didn't even want Visual Studio Code. So they built their own product called ZCrafter, used by them. They talk about speak English, not JCL. They created it's an absolutely beautiful website. And they've created it, and that's Eddie Cilantro. It's from 21CS. I think 21 Century Software. Oh, that's me. I didn't know why I made that comment. That's Lucas. But what they've gone and done, and I saw something literally just a few days ago, 4 days ago. The biggest player in Chicago tech is backing ZCrafter. ZCrafter is joining 8171. So right now they're all absolutely just living the dream right now. Private company of tech leaders, virtual capacities. So while they're still students at NIU, by basically, and also this is actually built, it's using some open source technology, is they literally had the need, it's very much see a need, fill a need of how they were able to create and build a product that's just given them huge amounts of eminence right now. And the entry level for that now is almost zero. I really feel that there's no barrier towards people self-publishing themselves and doing amazing things. And I really think it's very much, I think I'll stop sharing now because I'm just trying to think, I've only got 4 minutes. So it's very much, so if you look at anything in history, it's always, and I come back to the discovery of DNA, was actually discovered by a crystallographer, and it was discovered by a mathematician. And all the geneticists, and they're both students, they're called James Watson and Francis Crick, back in 50 something. I think they first discovered it. The people with ideas, people can get stuffy, right? I meet lots of stuffy mainframers who are like, oh, it's all about COBOL, it's all about green screen. Even now I meet people who say, oh, it's all about Visual Studio Code. It's not. There's so much. Those ZCrafter people built something completely different. The entry level now is I think is almost zero. It's just a question of kind of see a need, fill a need. Once you've got IBM Z Explore, then basically you can knock yourself out, because that platform, by the way, that ZCrafter thing, they're using the IBM Z Explorer as their back end. They just said, oh, let's build something new. They messed about a little bit. They got a little bit of help. The community sort of loved them. And now they've got venture capital. And I think, so I think that's really, really important to do. The last thing, I think on that, Akaji. So what you love and what you're good at, you're probably good at it. What the world needs is the world needs people to basically go into all of these companies, all of these banks, and sort of modernize it. Add the yeah, but all of those kind of smart, when you can just say to your curtains, close curtains, switch lights, talk to your Alexa and it switches the light bulbs on and off, and smart ring doorbells and all of that stuff. It's still an old building. The building can be like hundreds of years old, but basically modernize that and do that really interestingly. That's really, really the need. I don't know if anybody's got any questions. I've done lots and lots of talking. You can either go and work for an end user. So within the UK, Royal Bank of Scotland, NatWest, Scottish Widows, Barclays, HSBC, Next, Land Registry, just Lloyds Bank, just every single bank. If you're into counting money, if a lot of government agencies use, if you're Land Registry, Department of Motor Vehicles, what we call them, DVLA, we call them in England, you're going to be using a system, right? You're going to have been building this. You built this in the 80s and 90s and noughties. It's still running, but you're trying to get towards more. And the other really interesting thing that's going on right now, so you can go and work for one of those companies. Generally, those companies don't have IT departments that build their software. They're generally built by vendors. So you have companies like IBM, Broadcom, 21CS, HCL, Vitali is based in the UK. They're a specialist vendor. You can go and work for one of those companies. Or you also have lots of other companies. So like Microsoft, Google, AWS, they still have to make sure that all of the cool stuff that they're building blends and talks to mainframes. So you could become the networking required to do that, the authentication required to do that, to make sure that it's all of that lovely corporate data is safe, it's not getting hacked. Back in the 1980s, everything was kind of 8-bit computer, kind of like 128-bit encryption keys. All of that stuff is really weak right now. Even 256-bit byte encryption keys. There's quantum computers are coming out right now. They can attack traditional encryption. They can also be used to harden encryption. So all of these companies are crying out for people who have that.